In this section, I'm going to introduce the idea of a logarithm and a logarithmic function. Pay no attention to this 6.3. This is going to be 6.2. Okay, so let me introduce a logarithm. Recall that an exponential function is equal to y times a to the power bx. Well, let's let a equal 1 for the moment, and we'll create a new function, y equals b to the power x. Then I am going to define a logarithm as such. If y equals b to the power x, then log base b of y is equal to x. So this is read as log base b of y is equal to x. And this is just a new function. In fact, this is the inverse of an exponential function. If f of x is equal to b to the power x, then f inverse of x is equal to log base b of x. Since the log is the inverse of the exponential function, let's take a look at some domain and range properties. So recall that the domain of an exponential function is from negative infinity to positive infinity. And the range of an exponential function is from 0 to positive infinity. Recall also that it has a horizontal asymptote at y equals 0. So since the log is the inverse of the exponential, that means that the domain of the log is from 0 to infinity. Recall that the inverse swaps the x's and y's. That means that the range of the log is from negative infinity to positive infinity. And instead of a horizontal asymptote, we're switching x and y. So the log has a vertical asymptote of x equals 0. We won't need to worry about this until later, though, when we graph these. So let's rewrite some of these in logarithmic form. So I'm going to write the form over here. Y equals b to the power x, if and only if x equals log base b of x. This b is called the base, and it's written as a subscript, so it's a small letter by the tail of the g. Okay, so here we have 5 to the power 2 equals 25. So I can rewrite that as 2 equals log base b, log base 5 of 25. The base of the logarithm is the base of the exponent. Now let's look at this other one. 10 to the power negative 1 is 0.1. So I can write this as negative 1 equals log base 10 of 0.1. Here we have 8 to the power 2/3 equals 4. So 2/3 equals log base 8 of 4. There are a couple special logarithms that we use a lot in math. The common logarithm is just log of x. Note, this does not have a base. Actually, it does have a base, we just don't write it. So when you see log of x, that's really saying log base 10 of x. Since we have 10 fingers and 10 toes and we count in base 10, the common log is the base 10 logarithm. So on your calculator, you will see the log button over here on the left next to the 7. That is log base 10. Now let's look at the natural logarithm. The natural logarithm, or ln of x, that is the same as log base e of x. Recall the number e is the number we talked about last lecture. E is approximately 2.71828, etc. E is such an important number in math that it gets its own logarithm. So when you see ln of x, that's just saying log base e of x. And the natural log button is right here on your calculator next to the 4. So this log button is for log base 10. This button here is for the natural log, or log base e. If you want to use a log of any arbitrary base in your calculator, so for example, if you wanted to evaluate log base 3 of 9, you would press the math key and scroll down towards the bottom until you see the button log base. So log base allows you to put any base in the calculator. So log base 3 of 9 is equal to 2. Which makes sense, because if I were to change this back into exponential form, I would have 3 squared equals 9. And I know that that's true. Now let's look to convert these the other way. We want to write these in exponential form. So the base of the log is going to be the base of the exponent. This number over here is the exponent. So to write this log in exponential form, log base 2 of 16 is equal to 4. Rewriting it would be 2 to the power 4 equals 16. Now let's look at this one. Log base 4 of 1 equals 0. To write this in exponential form, I'm first going to look at the base. The base is 4. The exponent is 0, and that's equal to 1. I know I did it correctly because 4 to the power 0 is 1. Let's write these in exponential form. The natural log of 3x is equal to 7. Well, recall that the natural log is log base e. So this is the same as saying log base e of 3x is equal to 7. To write this in exponential form, the base of this log is e. So this is the same as writing e to the power 7 is equal to 3x. Now let's do part D. Log of x minus 3 is equal to y plus 1. Again, recall, this is a common logarithm. This is log base 10. So to change this in exponential form, base of the log is the base of the exponent. So this is 10 to the power, well, this is the exponent. 10 to the power y plus 1 is equal to x minus 3. Now we want to find the inverse of this function. And to do that, we're going to have to change it into logarithmic form. So the steps for finding the inverse. Step 1, we're going to change all the f of x's to y's. So this is y equals 1.75 to the power x minus 1. The next step in finding the inverse is to swap the x's and y's. So x equals 1.75 to the power y minus 1. Now let's change this into exponential form. The base of the exponent is the base of the log. So this is log base 1.75 of x is equal to y minus 1. Now to find the inverse, we have to solve this for y. So we'll just add 1 to both sides. So log base 1.75 of x plus 1 is equal to y. So that means that f inverse of x is equal to log base 1.75 of x plus 1. This is the inverse of our function. Now I want to evaluate some logs. Log base 6 of 36. Let's try to evaluate this without the aid of a calculator. Well, this is equal to some unknown value, so I'm going to set it equal to x. What this is really saying is 6 to what power is 36? So let's write this as an exponential. The base of our log is 6, so the base of our exponent is 6. X is the exponent, and that's equal to 36. So log base 6 of 36 is saying, or is asking the question, 6 to what power is x? Well, 6 squared is x, so x is 2. So the log base 36 of x is 2. Well, let's look at this one. I don't see a base here, do you? This is a common log, so the base is 10. Log base 10 of 1 over 100 is equal to some number. Let's say that that number is x. To evaluate this, I'm going to switch it into exponential form. 10 to the power of x is equal to 1 over 100. Well, what is that then? 10 to what power is 1 over 100? Recall that x to the power negative 1 is equal to 1 over x. And 1 over x to the power negative 1 is equal to x. These are exponent properties from Algebra 1. So I can say that 10 to the power x is equal to, I'm just going to take the reciprocal. This is 100 to the power negative 1. All right, we're getting closer. Well, 10 to the power x, I also know that 100 is 10 squared. So this is like saying 10 squared to the power negative 1. Well, anytime you have a power raised to a power, you multiply the exponents. So 10 to the power x is equal to 10 to the power negative 2. So that must mean that x is negative 2. And I can verify that by evaluating this in my calculator. Log of 1 over 100, since this is a common log, I can easily evaluate it in my calculator by pressing the log button. The log of 1 over 100 is negative 2. Let's evaluate some of these. Log of the fourth root of 10. Again, this is log base 10. And that's equal to some unknown number x. Well, let's switch this into exponential form. Oops. 10 to the power of x is equal to the fourth root of 10. Okay. Recall that the nth root of x is equal to x to the power 1 over n. That means that 10 to the power x, I can rewrite this fourth root as 10 to the power 1 over 4. So that means that x is 1 over 4. So log of the fourth root of 10 is equal to 1/4. Okay, let's take a look at this one. The natural log of 1. Recall that the natural log is just log base e. And let's set this equal to some unknown value. Well, I can rewrite this as e to the power of x is equal to 1. When is e to the power of x equal to 1? Well, recall that x to the power 0 is equal to 1. Anything to the power 0 is 1. So that means that x is equal to 0. And we can evaluate this in our calculator to verify we're correct. The natural log of 1 is equal to 0. That's all that I have. Thank you for watching.